So we're going to do a couple things today. I recycled part of this slide deck, so I apologize. But luckily, we're not going to spend too much time in PowerPoint. I'm going to go through some slides that really just kind of talk about, a little bit about what is big data, a little bit about, Microsoft's foray into it with HDInsight. And then we're going to do some demos. I'm going to warn you ahead of time, big data demos, not necessarily the most flashy. It's not like a Power View demo. But I do have some, really what I'm going to try to do is give you guys some guidance on how you can get set up with this type of environment in your own workplace, in your own sandbox, etc. All right? So without further ado, a little bit about me. I'm one of the folks who helps herd cats over here at Pragmatic Works. SQL Server MVP, I've been doing a lot of different things with data for a really long time. You can find me on Twitter at AJBigData or adamjorgensen.com on the internet. If you guys have your 56K modems dialed up, you should be in good shape. You can hit my site. A couple things we're going to try to understand: MapReduce, Hadoop, the Hadoop stack elements a little bit better. We'll talk about what those are. We're going to talk about Microsoft's Hadoop on Azure or HDInsight, as well as the Hortonworks data platform and kind of how those are sort of cousins, so to speak. So we want to make sure that we understand kind of the relationship there. We'll do a little bit of demoing on Hadoop and Hive and talk about how BI on big data works. We'll discuss a couple of the other tools like Scoop and Flume and some of these things as we go forward. Now, one of the things you're probably rapidly noticing is that everything in the big data space seems to have a funny name. One of the first things I want to show you before we jump into all of the pieces is kind of a real-world example of a company that's using a lot of these technologies. And one of them is called Cloud, which is a great way to sort of understand how you fare in the world of social media, how influential you're being in certain areas, and those types of things. For example, if I were to do Rachel's Cloud score, she'd probably be very, very influential in the area of miniature dachshunds. So, also very influential in the area of, puppies nobody should own.
Puppies, for sure, puppies.
So Cloud's big data makes all this stuff possible. So they process 15 social networks every day. That's not a very big number. Until you figure out which social networks they are. They're Facebook, they're LinkedIn, they're Instagram, all these major players. So they're processing about 769 terabytes of data storage a day, 200,000 indexed users, 140 million users that get indexed every day, 12 billion social signals processed every day, and over 1 trillion rows of data in their data warehouse. Pretty amazing, right? And right now you're thinking, oh wow, what kind of storage would we take to do all that, and how will we partition it, and how do they load all that data in, and what SSIS optimizations did they use? And I'm here to tell you, not much. So in reality, they've got all their signal collectors. They're using Pig and Hive, which we'll talk about in a little bit, to do some data enhancement. We'll call that data cleansing, in a more BI data warehouse kind of parlance. Then they've got their data warehouse, which is Hive, which is sitting on top of Hadoop. We'll talk about what that means. And then they've got a number of different platforms. They've got MySQL, they've got Hbase, which is a relational, truly sort of relational, transactionally consistent database that sits on Hadoop. They've got a search index. They're using Elasticsearch for that. They're using data streaming. And then they've got analysis services cubes. So they've got some pretty good sized analysis services cubes. And they're feeding in monitoring data. They're using Tableau for dashboarding. They're using Scala for analytics and event tracking. So there's a lot of things that they're doing and using a lot of different technologies. But if you notice, everything on the left-hand side, those are all big data type technologies, and they're the basis for everything. And they run on something called MapReduce. And the one thing, MapReduce can be very complex. We're not going to make it complex today. The most important thing for you to understand is how MapReduce works under the covers. So Hadoop, as we talk about Hadoop, is a program in a platform that comes with two primary things. It comes with a file system, a distributed file system called HDFS, which we'll talk some more about in a little bit. and it comes with a MapReduce protocol, which is the ability to essentially break a problem down and execute it in parallel. So when you give your input to a MapReduce job, it splits all those inputs up, and it goes out and finds the data that you're looking for, or begins to break the problem down into pieces to solve. Those individual pieces obviously create their output, and then that output is reduced or brought back into a much smaller form, and then the reducers send their output back to the final output, which gives you either your data set that you're returning if you're running a query, or it gives you the result of an API call, or it could be any number of different things. The important thing to remember is pretty much every tool in the big data workspace is there to keep you from having to write this kind of code in Java by hand. So if you need a lot of control and you really need to, really specifically control how many mappers get created and all those types of things. Right now, all you DBAs are like, well, I need it. I need the control. No, you don't. I promise. So Facebook is the largest Hive implementation in the world. They've got more Hive tables and jobs and data and all these things. Their implementation is very, very, very sizable. They run something like 85% of their jobs a few years ago used to all be hand-coded Java. Now 85% of them are just Hive queries, which you don't have to worry about any of this. It's doing all this under the covers, and you'll see what that means in a little bit. So we talk about HDFS. What's a distributed file system? Well, really all it means is the data gets distributed over commodity drives on commodity servers. So by default, your data is going to get replicated 3 times. So if you create a directory and load a bunch of files into it, that data is going to get replicated to 3 other servers. Do you tune that? Do you worry about it? No, you don't. It just handles it when you load the data. It's all done. So it's not only parallel, but we want to try to maintain minimal data movement to keep those network bottlenecks at a minimal pace. I apologize, my PowerPoint, my VM is running kind of slow here, so. I want to see all of these items. All right, so the Hadoop stack, there's more than this, but I just want to point out the most common ones. Obviously, Hadoop comes with MapReduce and HDFS, and we also have Hbase, which is a quote-unquote NoSQL database, but it is have some transactionally consistent properties. It's a little bit more of a more formal database than something like Hive. Hive gives you a SQL-like data warehouse system you can put on top of HDFS. So you can go actually say, I want to create a table called sales, and in this directory are all my sales files, and here's the schema for those files. Go create the table. And it will load the data into the table, or it will just create like a metadata view over top of all the files, so that when you load more files in, the data is automatically up to date, which is pretty cool when you're trying to load and work with trillions and trillions of rows of data. You don't have to worry about your batch processing as much and things like that. It gives you a lot more flexibility. Pig is a data workflow scripting or transformation language. So very straightforward and simple to use. I'm going to show you examples of both Hive and Pig in a little bit. Scoop gives us import-export capability between HDFS, Hbase, Hive, and a relational data warehouse like a SQL Server or Oracle, something like that. Flume is a tool that just gives us log file integration, so we can more easily integrate our log files. You can easily take like an Apache weblog file and drop it into a directory in HDFS and begin to work with it, but Flume just gives you a little bit of extra capability there. We also have Mahout. Mahout gives us machine learning and data mining and some more powerful analytic capabilities. Some of the things that you read about people doing in big data, a lot of them are doing it in Mahout, or at least starting there and then moving on to some more advanced things. So where does Microsoft fit in, right? So all that's open source compatible, Cloudera, Hortonworks, Yahoo, regular Apache, all these people. Microsoft said, hey, we want to play. So Microsoft Hadoop on Azure is a lot simpler. So you can spin up a cluster very easily right through the Azure portal. Of course, it's browser-based, so you've got all your provisioning. You can link up your Azure storage accounts You can link up your Amazon S3 account. You can import data from the data market directly into Hive, which is pretty cool. We also get an interactive JavaScript console, which I'll show you in a little bit. That's kind of like your Windows version of your Unix command prompt, but you're going to get a lot more functionality out of that, depending upon what you're trying to accomplish. We also have interactive Hive commands and a Hive console, so we can run through and do those. We've also got, of course, from the portal page, we can RDP directly into our node. So we have a number of pieces of functionality. You'll see all that here in a little bit once we jump into the demo. Hive is essentially a program within Hadoop that allows us to put a table-like structure over top of our data, or to actually create a table and load the data in. It's used by most BI products that connect to Hadoop, so tools like Power Pivot, Power View, Analysis Services, even competitors like Tableau or Cognos, who have connectors. They all connect through Hive. They built a Hive connector. So they use an ODBC driver that's published by all the major manufacturers or just distributors. So Microsoft's got one, Hortonworks has one, Cloudera has one. And the query is going to generate that MapReduce job that we saw in that complicated diagram of the spreadsheet. We just have to write a query, and it's going to do everything else under the covers. Like I said, Microsoft has their own ODBC driver. So does everybody else. Pretty easy to get. Now, one of the things you'll see here is pretty easy to start working with Hive because we already know the commands for the most part. It's a little bit closer to ANSI SQL. It's not true T-SQL. But certainly it's very easy to do create table, alter table, drop table. We're going to do an insert, an overwrite if we need to, select, join, where, group by. Sorting can be a little tricky, but you can still do it. Fully functional there. And then we've got the capability to pass in, jar files and things like that to be able to, customize our map or our reduce end of that equation. So some pretty cool functionality there in Hive. So instead of SQL, Pig employs a language called Pig Latin. I know, I don't make these things up. It accommodates data flow expressions. So you can do a combo of query and ETL. It's kind of said 10 lines of Pig Latin is about 200 lines of Java. It works with both tabular and unstructured data, which is really nice, and you'll see an example of that. As with Hive, we're going to generate a MapReduce job. The difference is, unlike Hive, the output is only to a flat file in HDFS or to text at the command line prompt, so it doesn't go into a table. It's going to go into a file. A lot of people will use Pig to do some data organization and cleansing and then output it to a file in a directory in the format that they know the Hive table is expecting, so that automatically updates their Hive tables. So there's some pretty, some pretty good stuff that you can do by combining those two tools. There's a Grunt command line or Grunt shell. You'll see what that looks like here in a little bit. This is an example. So first we can just say A equals load my file, as my 3 columns are X, Y, and Z. Then we're going to set B equal to all the rows. We're going to filter those out. So we're going to say get rid of anything in A where X is not greater than 0. Then we're going to group by our first column, and then we're going to take those results, and we're going to generate a count for each one of those, and we're going to store those into our output. So very, very simple, straightforward. I like to tell people, think about if you took what you were doing in an SSIS package and you just took each component and said, it wrote in one sentence what this component is doing. That's basically one line of Pig. So there's some very cool things that you can do in here. It's just not graphical, right? Is that coming? Probably at some point, but probably not in the next 6 to 12 months. So there's a lot of filtered commands, or Pig commands rather, that we can use. We can do load and store. There's for each. We can loop through. We can do joins and filters. It's very, very powerful, very, very fast, because every time you ask it to do something, it kicks off a MapReduce job that is going to allow you to go out there and actually do some of these things. All right, so I've got a few resources for you here at the end, but first, let's go ahead and take a look at a demo. So to avoid any issue with the cloud, and because I wasn't 100% sure that, that I would be here today, I'm going to go up here to windowsazure.com, and right now, if you're interested in doing this on the cloud, you can come up here and take a look at features. And here's all their big data functionality. And you can get access to the developer preview. Now, what they're doing is they're granting this access as they add capacity. So, you know, just be patient with them if they're continuing to, you know, to take some, you know, a couple weeks to get you access. In the meantime, you can explore all of these different tools and different things and all of the documentation and white papers. It's all out here. The other place you can go is Microsoft.com/bigdata. Come on. There we go. And if you scroll all the way down here to the bottom, you can read about all their offerings, etc. If you scroll all the way down here to the bottom, all the way down, you can download the HDInsight server. This is absolutely beta. I'm telling you straight up. You may run into problems installing it, just depending upon your environment. The best environment I have found to install it in is a Windows Server 2008 R2 single machine. It only supports single machines in the on-prem version right now. On top of that, when you install it, you're going to get this nasty error when the dashboard loads. It's going to be a side-by-side configuration error. You just need to make sure that you update your C++ redistributor file. If you Google the side-by-side configuration error, it'll tell you, hey, this is going to be an issue with your C++ file, and you just need to go out and get the updated one. It's free download from Microsoft. You just need to go find it, depending upon how many patches your server has and that kind of thing. All right, so that's how I set this environment up. And so you'll notice just a regular old, very simple Windows Server 2008 R2. I threw Firefox on here just because I get tired of dealing with Internet Explorer's enhanced protection, and it throws errors at me and annoys me, especially on internal demo machines. So, so once we have this set up and we run the install, which obviously I'm not going to do now, we can go to our dashboard, and we'll get these shortcuts on our desktop here, and I can open this up. And it's going to go right to my dashboard and show me all my clusters. So my only cluster I have on here right now is my local cluster. And you'll see immediately I can go to Getting Started, and I've got all kinds of little training and support forums, which actually have some good information in them, release notes, some examples, all that kind of good stuff. Or I can go back over here. We have an interactive JavaScript console where I can run commands that are, you know, we'll call them similar to, you know, like a Unix environment. So I could say like ls, for example, and I can see all my, you know, some files right there on my root. I could remote desktop to this cluster. It's run if it wasn't running right here locally. That's going to be a problem. I can see my job history. So right now I haven't run any jobs since I restarted the server right before the demo. So we'll see that again in a little bit. When you want to connect your BI environments up, this is the driver that you need. You cannot download this driver unless you install this or get access to a cloud system. You can only get it through the install. There's no public download for the ODBC driver. If there is, somebody posted it on their website, and I wouldn't trust that copy. All right. There's also the documentation page, which has a lot of good documentation, quick starts, tutorials, all that kind of good stuff. All right. I've tried to use data in my demos today that is freely available through the Microsoft demos and walkthroughs, so that, you know, it won't be foreign if you go back and watch my webinar and you're trying to also run through some of the documentation. All right. We can also come down here and, for example, create a Hive job. So I can write a query that says show tables, and it's going to run over here. which is, and then when it comes back in a second, we can see those results. In the meantime, I could come over here to deploy samples, and I've got sorting, estimating, word count, scoop demo. There's a whole host of things that are, that are out here, so you can just play around with. Very easy to, deploy this. You just hit deploy, and it pushes all the files out that you need. And then it gives you the example files and walks you through, what to type and all those kinds of things to go out and execute it. All right, so pretty cool stuff. See, I've got my first job history. Pretty cool. We can look at our log. So it took about just under a second. Here's all my tables. Here's my output. Not very fancy, right? I'm going to warn you ahead of time, working in a Hadoop environment is not the most glamorous thing in the world. You do a lot of things by command line. And in that spirit, that's what some of the demos are that I want to show you today. So if we pop over here and we open up our Hadoop command line, and I get kind of a nice clean command line. Now, I'm going to be totally upfront with you guys. I am absolutely cheating. Whoops. That didn't work on that side. So rather than watch you guys, have you guys watch me type, I went ahead and pulled some of these samples together. Now, a couple of the nice things in this environment, when you install it, you can go to your C drive under Hadoop, under the Getting Started folder, and there's a data generator. And you can actually use this README file, and it'll let you see how you can generate actually some pretty big data. I've got a, is this my 2 gig file? Yeah, no, that's my 2 meg file. I have another file somewhere that's a 300 gig file. I just had it write me one out, and I don't have it on this VM. It just takes too long to do stuff with, but it's great for MapReduce testing. So it's also got some Hive in here. There are some pig examples in here that we can run. So there's a lot of really cool things that we can do. Before you get started, the first thing you want to do is go into that Hadoop folder and run this start onebox.cmd. Whoops. Oh, I was one directory back. What this is going to do, and I'm just showing you this, I already have all my services running. It's going to go through and check and make sure every service for that data platform for Hadoop is up and running. And if it's not, it's going to start it. So it's kind of meant to be your kickoff, so to speak. All right. So now that we're over here in our Getting Started folder, there's all kinds of things that we could come down here and do. So I can run some samples. I can pass in some parameters to that if you notice. There's our relatively simple PowerShell statements. These are all included, by the way, so you can see some pretty good things there. And you're going to basically pass in, if you want to run the pig samples or the Hive samples, it'll jump down here and get the right information to execute all those. We're going to shortcut some of that, and I'm going to just give you a few things that are probably a little bit easier to run with. All right. So we'll start with some simple Hive demos that I've pulled together here for you. Whoops. Hang on. Let me just give myself a little bit more real estate. There we go. Sorry, y'all. All right. So we've got some simple Hive queries here. I'm gonna go through each one, tell you exactly what it's going to do, and then we'll run it and we'll see the output. Okay. The only reason I have them in here like this is so that you don't have to sit here and watch them type. Okay, so very first thing, we can run this import data. So we've got a PowerShell script that's just going to go out and say, run this import data PowerShell script. It's going to go out and just grab some data and import it into a few tables in Hive for us. I'm going to go ahead and run that just to get it imported. So it's generating some text files, and then it's going to copy those text files over into HDFS for us. By the way, you can do all this manually in the script or the actual steps. Doesn't take very long. It's kind of a good exercise to walk through and do it manually. The other option is we can run the data generator tool, and I'll show you how that works here in just a second. The big reason I want to go through these examples is because in a week when you come back to this and you want to try to figure out how to do some of this, I want to make sure you have kind of a step-by-step in the command line, which I know the command line can be a little tricky, but you know, it's not really difficult stuff we're doing in the command line. A lot of it is just things that you would do normally in like a SQL Server data tools or query analyzer or something like that. That's really what we're doing here in the command line. Once we do a couple of these things, then I'll show you how the BI stack kind of connects up to it and how it works. All right. The other thing we could do, so now we've got all that data there, we can also go into our data generator folder and run this, and this is going to generate a 50 meg file and put it in my tutorial folder, and it's going to be called traffic.txt. It's just some sample highway traffic. It's a little data generator that Microsoft gives out with their distribution. All right, so that'll just take a couple seconds. And if we come over here, we can actually see that file just got created. So it says 128. My clock is on a weird time zone here on my server. I didn't change it yet. So apologies for that. So now that we've got some data, so just raw data sitting out there, these are just text files. Let's take a look at it real quick. So the traffic data is pretty straightforward. Of course, I should have thought twice about opening a 50 meg notepad file, but that's fine. We'll just give it a second. It'll catch up. All right, well, while that's running, we'll come back to that guy in just a second. So one of the first things that we can do before we do anything is we want to actually put this data into some kind of table in Hive so we can work with it, right? So the first thing I'm going to do is I'm going to start Hive by typing Hive. And I should get this little message that says it's all started up, and I get a Hive command prompt, and I'm good to go, okay? So the first thing I'm going to say is I'm going to drop my old table if it's still there. Always ending with a semicolon, by the way. That's going to be a big difference for a lot of people. So, okay, so the table's dropped. Next thing I'm going to do is copy and paste in this long create table statement. And if you'll notice, oh dear, I hope that's going to run. If you'll notice, it's very similar to our normal SQL command create table statement. And so we're creating a table called C. All of these columns, mostly of type string, a couple of type int, and then we're just going to say the row format, by the way, is going to be delimited. I'm sorry, it is delimited. We'll tell it what it's going to be delimited by when we put data in there. But it is delimited, and the fields are terminated by a tab. So very, very straightforward. This may not run because it's got line breaks in it. Okay, never mind, no problem. So what I can do now is say select star from W3C, and there's nothing in it. So I didn't get anything back. Still took half a second. So the next thing I want to do is actually load some data. So the best way to do that is with a very handy load data statement. So again, I'm just going to say I'm going to load data. It's local because it's on the local file system. I'm giving it the path. This is the text file I want to load. And we're going to overwrite that table. Anything that's in there, I just want to refresh it. Okay, I'm going to add a semicolon. And it's copying that data over. That'll take just a couple seconds. And then we should be in pretty good shape. That's a fairly good sized file. I think that's about a 2 gig file. Yep. So about a 2 gig file. And the goal here is we want to get this data into Hive so that we can go consume it with something. Right? So we've got all this big data out there. We've got all these files. What we're trying to do is just walk through a very simple example of how you can take some data that you might get that's a log file or a marketing file or customer information or just any kind of general data and get it loaded into HDFS through Hive, and then you can connect to it from every other tool. And that's really the benefit there. So now if I say select star from W3C, limit 10, I get back all of my rows, right? So pretty good stuff. I'm going to clear my screen. Whoops, I forgot that doesn't work there. Aha. Next thing we're going to do is run a couple sample queries just to get a sense for what the Hbase syntax looks like. So if you'll notice over here, we've got select. We're going to filter this column. We're going to round this up. And then we're going to do a subselect. All of this is very, very similar standard type of SQL operations. Okay, very easy to learn how to write Hive queries. Very, very simple. Now I'm going to paste this one in, and we're going to run it. And you'll see here we've got total number of MapReduce jobs is 1. We're launching job 1 out of 1, so it's not a ton of data, so we don't need all these different jobs. It's also giving us a job number and a tracking URL, so we could always hit that URL. So if this job is going to run for hours, for example, we could hit that URL and constantly get the status. Instead, we're going to come back over here to our job history. And in a minute, that job history will should be updated. And then we can also come over here to our MapReduce status. And it's showing us that there's a running job. Nothing's waiting on it. It gives us all of our data on the job right here. Right? Pretty good stuff. So let's open back up. So now you're actually seeing all the individual reduced jobs running, right? So we're sorting through that 2 gigs of data right now to return my query, which is going to actually tell us the average time that it took for each one of those pages to load in that W3C data. So we'll see which ones are going to be sort of the highest average time. And it's crunching through all 2 gigs of that data as we go through. The nice thing is you can see if any of these reducers fail, the task tracker knows that and it kicks them back off, potentially on another node if we had a multi-node cluster, just depending upon which environment you're in. So there's a couple other examples over here while that's running. We can also do things like hits by page, things like that. So errors by page, just in this data. So one of the things that's really important to remember is you're probably thinking, I could have built an SSIS package and loaded this data pretty quick, and I could have done all this in SQL Server, right? You're absolutely right. You could have, except for the fact that what you really want to be able to do is not have to worry about the data. You don't have to worry about the ETL job. You don't want to have to worry about any of that. Once you build this, you can drop as many of those files in there as you want, and Hive will just be up to date if you build in what's called an external table. So you have the ability to essentially surface up all of this data in different views from the end user perspective and do like for example, your average time taken per hour, or your hits by page by hour and things like that. So I'm using very simple examples. What I would encourage you to do is, think beyond some of the simplicity of some of these examples. And a lot of times you're going to have to manipulate this data and get it kind of whipped into shape before you can actually load it into Hive. And in order to do that, we need to use Pig. Pig is a lot more, I don't know if I'd say it's a lot more straightforward than than potentially using SSIS, because I'm a big fan of SSIS, and it does a really great job. But a lot of times what you're going to do is you're going to use Pig before SSIS. So it's going to be working on data, potentially dumping it down to a file, and then you're consuming that into your data warehouse, or potentially using it in Hive. The trick for Pig is everything is sort of an alias, right? So the first thing you're going to do is say logs is equal to the loaded value of this file, right? Then you're going to hit enter. And then you're going to say the levels, though, are going to be calculated for each one of these files. We want to use a regex and generate a level for trace warning and debug warning and info warning, warning, and a fatal warning, I think is the other one over here. Yep. And we're going to call that log level. Then we're going to use log level in the next row, and we're going to say filtered levels only give me log levels that are null. So if there's no trace values, I don't want to see them. Now group them, and group them by their log level. So up until the end of this, we still have all the raw rows, right? Now we're going to group them. And when this is finished, we'll come back and take a look at that in a second. And then for each group, count the occurrences in all the log levels. So now that we've grouped them all up, figure out if there are 10 debugs or 20 debugs or 50 errors or 20 warnings. Very simple syntax here. We're just doing counts and filters. Then we're going to sort the frequencies by count descending, and we're going to write the result into a file. And then I've got a couple of these little placeholders here because that's what we're going to use to go query it. So we're going to run this in just a minute, and we'll see what it does. Now, some of you are thinking, oh, I could probably do most of that in T-SQL too. Well, you could, except imagine if you had 5,000 of these log files, and you got about 500 of them a day. Right? You would really want to be able to run this as a job and have it spit this information out so that you could take that and use it somewhere else. Right? That's what we're going to do. Without having to load it into a SQL Server database or write .NET code or write Java code, this pig scripting allows us to be really pretty powerful and pretty flexible. Plus, it supports the full range of regex, which gives it a lot of capabilities. So we'll come back and run this demo here in just a second. And you guys will see the output, and I'll show you kind of how we go and get that information. But let's take a look at our Hive job here. So Hive finished, 4 minutes and 33 seconds. It used 9 maps and 3 reducers. That seems about right. Cumulative 273 CPU seconds. How many HDFS blocks or HDFS reads were issued? 6 HDFS writes, so not very write heavy, which is good. And we've got some good results here. So what this has done now is it's loaded all of that data into our table. And now that we want to go play with that, how do we do that? Well, hopefully you've installed the ODBC driver, which is just a next finish kind of install, very simple. And you can come over here into your ODBC panel, and this normally wouldn't be here. So I've gone in and added that. So I can say add, I can pick Hive, and normally I would say finish, and I'll get a screen that looks like this. And so you can point it at your Azure cluster. There's lots of good articles on the web if you get on the Azure cluster on how to connect up to the Azure cluster and things like that. Your ports default, no authentication since I'm here locally. Again, very simple configuration information. Sorry guys, I'm just making sure nobody's having audio problems. Okay. So once you've got that set up, then you can come in here to Excel and Power Pivot, or any other tool that will support ODBC for that matter. And I can say get external data from other sources. I can come down here to my OLEDB ODBC, and I'm just going to build a connection manager. So my provider, of course, is my ODBC driver. My data source name is Hive. By the way, if you do this and you set up your ODBC and it doesn't show up in this dropdown, chances are you didn't create it in the right place. So if you created a weird kind of DSN or something like that, it's not going to show up in the right place. I don't need to worry about a username and password because it's local and I have not set one up for Hive. You may set one up if you'd like to, and then of course you'll need to put that in there. For the initial catalog, it's just a default database, so no problem. And on a test flight connection, everything looks good there. And we'll say, OK, next. And now we're right back into standard Power Pivot, right? So I'm going to select the list of tables. I'm not bringing in all that W3C data. That's the 2 gigs of data. That's going to take too long. So I will just bring in the traffic data that I loaded earlier. And we'll say finish, import in progress. Again, now we're back into very traditional, very standard SQL Server BI. Now, some of you may say, well, but Adam, we can just import flat files into Power Pivot. Yep, you can. But again, when you go to reprocess, you're going to have to make sure that those new files are selected and all those kinds of things. And that can be a challenge. So what you're better off doing is building these things in Hive, leveraging the tools and capabilities from Pig that will clean and or help you organize and prepare that data on its way in. So I think this was a 50 meg file, so I'm going to let that run for just a minute. And we're going to come back over here to our command line. And let's take a look at the Pig example that we had. So the first thing I'm going to do is quit Hive, and I'm going to come back over here, and I'm going to go to my, I always create a tutorial folder just locally here, or just one folder where I put everything. It makes my command line life a little bit easier, so I'm not having these really long file paths. And so now I can say something like Hadoop file system, I want to put my sample.log folder into HDFS, and I'm going to call it sample.log in HDFS. And since I already have one there, chances are pretty good it's going to tell me it's already there, so no problem. Otherwise, it would just write it there, and you wouldn't get a lot of information back. It would just not give you an error. So the next thing we're going to do is I actually have all of these queries set up through here in a very easy sort of automated batch file. What does that look like? It looks exactly like this, minus the first and last 2 lines. That's it. There's really no difference. So what I'm going to do is just say pig, and then I'm going to say pigdemo.pig. and it's going to go out and run this file. At least I think it's going to. Looks like it succeeded successfully. Shouldn't be too much work for it. So I'm going to go out and say Hadoop file system. Whoops, file system. And by the way, for those of you who've never seen any of these Unix or Linux tools like cat and grep and those types of things, you know, they're really dusty to me too. I haven't used them in a while, but start dusting those off because a lot of them have made their way over with Hadoop because they're kind of necessary. So we'll say, let's find this sample out, and I want partition R 0, 0, 0, 0, 0. I'm just copying this here over from the left, guys. This is just I saved all my code from earlier. All right, so again, we processed through a pretty good amount of data with that pig script, even on one node, you know, pretty quickly. So one of the things that, you know, for example, SQL Server and any relational database doesn't do a very good job of is looking at things line by line, right? I think we all know that. This is able to go through line by line. It can handle, you know, little inconsistencies with the data and things like that. And it gave us a pretty good breakdown of, you know, what some of those types of things, you know, really look like as far as the counts for all those different types of, you know, warnings. So this could be something that's happening, you know, pretty regularly throughout the day as data comes in. You know, you could process it, spit it back out, process it, spit it back out. So it's actually a pretty, you know, pretty good way to go in and approach it. I can also clear all this out by saying Hadoop file system remove recursively all of my sample out files. And that should run, moved it all in the trash, and we should be in pretty good shape. Now, if we come back over here, I don't know why that's still running. That's disappointing. Let's try, let's go get something that's a little bit smaller. I'm going to go through it this time a little bit quicker, just to be sensitive to everybody's time. Lovely. Well, I'm not sure why the import was taking that long. I probably should have just let it finish. But this is all log data over here that I imported just before the demo. So you can then take that once it's in PowerPivot or really anywhere else that's ODBC compliant and begin to use it for visualization, really use it for anything else. Good, our test connection succeeded after taking just shy of forever. There we go. So we added another tab. I just re-imported the logs data just so you guys could see the ODBC file work. And now we're in PowerPivot. So now we can do anything and everything that we would normally do with PowerPivot data, including mapping, you know, any kind of visualization, reporting, self-service exploration, you know, any and all of those kinds of things. So, you know, a couple of things I would encourage you to do around this space. One, you know, just start using some of the samples that are out there, right? So if you start putting them together, you know, it's a really good idea to, you know, understand kind of how some of these things are working. I'm going to take a look at our MapReduce job here. And really get a sense for some of the things that you can do with it. My best piece of advice is walk through the Hive and the pig demos and then start to think about what kind of data do you have in your organization that you can start, you know, leveraging and playing around with these types of solutions with. It's a very, very cool space. There's a lot of additional resources. Sorry about that. There we go. So, obviously we've got a number of different solutions and applications and platforms that will all use ODBC to connect. That's not going to be an issue for you to find something like that. But again, in Microsoft BI, that's Excel, Power Pivot, Power View, reporting services, SharePoint, analysis services, and even any ISV or third-party applications. So we already went through the demo, so I'm going to skip that slide. This is what the cluster request page will look like in the Windows Azure Big Data Portal when you get your invitation code after you submit. So there's a good chance you'll see this. I left this slide in here because it takes about anywhere from 15 to 30 minutes for the cluster to spin up, and that's obviously need to be done before a webinar or a presentation. So there's a bunch of good resources out there. The Apache Hadoop homepage, Hive and Pig homepages. There's actually a lot of really good documentation out there on those pages as far as how to write queries and how the system works and those types of things. And of course, the Hadoop on Azure homepage, which is now just the Windows Azure homepage, Cloudera, Hortonworks, MapR, they all have good, good distributions for you to kind of play around with if you, for some reason, don't want to run it on Windows. And then, of course, the SQL Server 2012 Big Data section on the Microsoft website. There's a lot of good information there as well. All right. So without further ado, obviously there's past resources. There is a Big Data virtual chapter that's been having some really, really good sessions lately, and I think that's going to continue. So if you guys want to check that out, make sure you go to sqlpass.org and check out the virtual chapter session. All right. So thank you for attending this session. Obviously, if you didn't go to Past Summit, don't worry about that. I'm recycling the slide deck. But I just wanted to make sure we got to cover most of the demo stuff, so I didn't want to spend as much time on the actual slide deck. So with that, I want to leave a little bit of time here for questions. I think we did.
Yep, we did. All right. So one question we have is, why don't you use Impala instead of, I don't know how to say this, SQOOP, Scoop?
So Impala is, really a whole suite of functionality. Scoop is I need to get data out of this and into this. So Scoop is going to be a lot more lightweight to use, but it doesn't mean that Impala is not a great solution. Impala is just literally brand spanking new. So we'll just have to see how all that evolves. Plus, Scoop is an open source program, and Impala, while it may be contributed back to open source, is primarily driven by Cloudera. So if you're not using a Cloudera product, it's not that it won't necessarily be compatible, but it's just extra confusion in some cases. So good question.
Okay, great. Is there a benefit with Microsoft Hadoop Suite in comparison to Apache Hadoop framework, with the exception of Azure?
So the big benefit is going to be in what Microsoft's adding to it. So obviously with Apache Hadoop, you don't get things like Active Directory integration, the security and the caching, and all those types of things. So Microsoft's working very closely with Hortonworks to make sure that those things are being contributed back into the open source branches. But obviously that stuff takes time, right? So from a Microsoft perspective, now that it's rolled into Azure, it's going to be supported, and all those types of things. So if you go to call Apache for technical support, there's nobody there to answer the phone. So from a Microsoft perspective, the code and the functionality should be very, very, very similar. They all are working off the same open source branches. So you really shouldn't see too much of a difference. If you've already got a good Apache Hadoop setup running, then keep going with that. What I would encourage you to do is take some of those jobs and just come try to run them over on a HDInsight implementation and just kind of see what works for you and what doesn't. So.
Okay, great. And let's see, where does Hbase fit in?
So Hbase is the ability to take the Parallel Data Warehouse appliance, and it's a feature within that appliance that allows it to integrate directly with the Hadoop file system. So you can just literally kind of get to skip Hive, although it's doing some Hive under the covers. You can essentially run a select statement that queries a relational table on the appliance and a file system on Hadoop and brings all that data back together in one query. So, but it's specifically limited to the parallel data warehouse appliance.
Okay. Is the data set up to eventually be imported into a relational data warehouse, or is it more for ad hoc queries?
Really both. I mean, you can set up self-service users very easily on Hive. It's a great way to just kind of dump some data into a few places and let them begin to explore it, maybe even something like Data Explorer. But a lot of customers are using it to cull through a lot of this, quote-unquote big data or, high-volume data or sort of multi-structured data and get it into a form quickly and easily without having to write a lot of complicated script tasks or, Java code to ultimately import a selection of it into the relational data warehouse.
Okay. How is big data implementation different in Microsoft than that of its competitors?
It's all about which features they're paying attention to versus the others. I mean, I would recommend reading up on the other competitors. I don't have anything negative to say about them. I mean, everybody's got some really great things going on in that space, and they've all got their own sort of VM sandbox download that you can get up and running pretty quickly. So the biggest thing is Microsoft wants to add real supportability. They want it truly integrated with the rest of their data platform, so that's really the big differentiator. The other companies just do this. They don't have any other tools that really, I mean, they may have some other smaller sort of functional tools, but even things like Impala, there's a SQL Server engine to go along with this. There's a parallel data warehouse appliance to go along with this, and there's all of the features that are coming, like adding column store functionality into Hive, and all of these Active Directory and security and compliance and all those kinds of things. So that's where Microsoft has always ruled the roost, and they're going to continue to do that with this platform. But it doesn't mean that in order to prototype something, you can't get it up and running in another one, and then when you need those features, see where Microsoft is at.
Okay, great. And unfortunately, guys, we only have time for one more question, so here it is. What is the difference between this local installation with HDInsight on cloud? I'm not sure if I understand that question.
The biggest difference is, well, there really is no difference. So if you get an Azure cluster, you can click on remote desktop and you will be doing exactly what I'm doing. Or you can do it all through the portal. The portal to me is more for just kind of seeing what's going on. I don't really use the portal for what I'd call development, right? So but the actual MSI that gets pushed when you install the cluster in Azure is the same as the MSI that you download to install in your local server.